Chapter 9, Question 18. This also is one that we're going to want to set up in a table. There's other ways to do this, but let's just take this approach and see how it works. So again, you should read through the question and see what the details are. But we've got a virus. It either infects somebody or it doesn't infect them. People are infected or not infected. So those are one aspect of it. And then the other aspect or event that we're looking at is that they either test positive or they would test negative. They don't say that directly, but the test result of whether or not they have the virus is the other aspect. So the way I decided to do this is I'm going to put those who are infected with the virus here. And so the ones who are not will be here. Not infected. Then for the test results are either going to be positive or negative. So I'll put the positive test results here, the negative test results here. Positive means they tested that they have the infection. They may or may not have it. Negative means they tested to not have it. And again, they may or may not have it. We don't know. So what we have to fill in the tables here, though, is kind of how we go through this. We know that a certain virus infects 1 in every 400 people. So of the people who are infected, there are a total of 1 person for every 399. So there's our 400 people. 1 person got infected, 399 didn't get infected. So that gives us a total of 400 people that we're working with. Of those infected, 90% will test positive. So what we do is we take this 90% times the number of people, and that gives us a number we're going to work with. This is kind of strange, but it's 0.9 of a person. But we can kind of deal with that as a percentage of some sort, but it's a way of counting. So if 90% that who are infected test positive, how many would test as negative? Well, that's the complement to 100, so 0.9 and 0.1. So 90%, 10% times the 1 person, that gives us 0.1. 0.9 plus 0.1 is 1. Okay. We'll do the same thing over here with those who are not infected, but it's kind of different. If they're not infected, the positive test, it must be that 90% of these infected get positive results. So 90% of the positive results are people who are infected. That means that there's 10% of the positive results for people who are not infected. Again, using that idea of complement. So 0.1 times 399 gives us 39.9. And then, using the complement of 0.1, there's 90% who would test negatively. So we take that times the 399, and we end up with 359.1. These are strange numbers to work with. They're not whole people, but what it's going to do is you're going to see is the numbers will work out and we'll get correct percentages. What we could do is deal with more. We could deal with 4,000 and our numbers might look bigger, better. But I thought it was more intuitive to go with just talking about 400 because that's what the problem talks about. So if we add across 0.9 plus 39.9, we get 40.8. We add across here 0.1 plus 359.1, we get 359.2. If you add these two together, you will get your 400. So we've counted appropriately. After all that, we are now set up to start answering the questions. The A part simply asks, what's the probability that A happens given B has already happened, or we know that B has happened. B is the event that the person tests positive. So we know we are in this area. We're in this area, this row. And the event B is the event that the person, the event B is that the person tests positive. The event A is that the person is actually infected. Okay, so let's get this straight. We're dealing with this row, so we know we're dealing with a total of 40.8, and those who are infected would be 0.9. So that's our probability. We're going to turn that to a decimal, because the back of the book actually has its answers as a decimal. Because the other way of dealing with this is with percentages, but we're going to go this way. 0.9 divided by 40.8 gives us a 0.022, which is the answer you'll see in the back of the book. Turning it to a percentage is 2.2%. So what does that mean? That means if the person tested positive, so we're here, that there is a 2.2% chance that the person actually has the virus. Doesn't seem so good. Okay, so the person tested positive, 2.2% chance that they actually have the virus. The B part is going to ask the probability that sort of the reverse, not A given not B. Now what's not B? Not B would be that the person would have tested negative. So we're going to be dealing with this, this row here, the negative row. Okay, so we look here, the total is going to be out of 359.2. And then what is not A? Not A means they're not infected. So that would be this number here, 359.1. So that gives us a number, when you divide these two, of 0.9997. You had to go out. If you rounded too soon, it looks like 100%. So this is a very, I guess, a good chance. If you've got a negative test, there's a very good chance that you're not infected. That's what kind of we're looking for. But let's turn that into a percentage. Yeah, 99.97%. Seems very strong, but let's do this. This is a 10,000ths place, right? 4 places. So that, as a fraction, is 9997 over 10,000. So let's put this in perspective. If you've got a negative test, 9,997 out of 10,000, you don't have the virus. But let's think in the contrary. It means that 3 of these people who got a negative test actually have the virus. They're going around maybe infecting other people because they think, I've got tested, I don't have that virus. But they actually do. They actually do. And that's what this one shows. So I hope this was helpful. Set up your table, do the counting. You're either dealing with a particular row or a particular column, depending upon your setup. Thanks.